Assalamualaikum and good evening, madam. Today we are going to present on ethics in engineering. We chose to indulge deeper on the Tacoma Narrows Bridge that was collapsed in the 1940. The Tacoma Narrows Bridge, nicknamed as Galloping Gertie, was a suspension bridge in Washington state that dramatically collapsed on November 7, 1940, just 4 months after its opening. The collapse became one of the most iconic engineering failures in history and reshaped the field of structural and aerodynamic engineering.
However, what caused the collapse? First of all, aeroelastic flutter, not simple resonance. Contrary to popular belief, the bridge did not collapse due to classic mechanical resonance. Instead, it fell because of aeroelastic flutter, a self-exciting and self-amplifying torsional vibration. In this phenomenon, wind-induced forces coupled with the bridge's structural dynamics led to oscillations that increased in amplitude until the structure failed. The design flaws. Narrow and flexible structure. The bridge featured a slender deck supported by solid plate girders rather than open trusses. This design choice made the structure more flexible and susceptible to wind-induced oscillations. The use of shallow stiffening trusses failed to provide adequate rigidity, allowing wind forces to induce significant vertical and torsional movements. Lastly, one of the reasons the bridge collapsed is because the ineffective mitigation measures. During construction, engineers observed the bridge tendency to oscillate in the wind. Attempts to mitigate this included installing hydraulic dampers and tie-down cables. However, these measures were either ineffective or failed due to design and installation issues. For instance, the hydraulic damper seals were compromised during sandblasting, rendering them non-functional. That's all.
Now we move on to ethical and engineering oversight. While the collapse was not due to deliberate unethical behavior, several oversight highlight lapses in engineering judgment and ethical responsibility. The first one is neglecting aerodynamic consideration. The design did not adequately account for aerodynamic effect, a critical oversight given the bridge location and exposure to wind. Second, ignoring early warning sign. The bridge exhibited significant oscillation even during the construction. Despite this, it was open to the public without fully addressing this issue. And last is inadequate testing and analysis. The lack of comprehensive wind tunnel testing and failure to model aerodynamic behavior contribute to this disaster.
The collapse of the Tacoma Bridge in 1940 have led to significant advancement in engineering. For example, engineers began taking the environmental and natural surrounding into consideration when designing their projects, thus reducing any damage by the nature that can be done to the building itself. Furthermore, repeated testing has been implemented during construction, so any defects and problems can be detected early and thus fixed before it causes any problems. Lastly, since the collapse of the bridge was pretty famous in the engineering world, it has been embedded in most engineering disciplines and studies, serving as a cautionary tale so future engineers can avoid making the same mistake.
The tragic collapse of the Tacoma Narrows Bridge in 1940 served as a powerful reminder that engineering is not just about calculations and materials. It is also about understanding the environment and learning from early warning signs. Although no human lives were lost, the failure had profound consequences. The Tacoma Narrows disaster wasn't just a failure of steel and concrete. It was a failure of foresight, testing, and professional duty. But from it rose a more rigorous, thoughtful, and safety-conscious era of engineering. That's all from our group. Thank you.